Hello, this video will go over lesson number 2 in the probability unit. It covers independent and dependent events. This lesson will teach me to identify independent and dependent events and find the probability of two events. Definitions and formulas. Independent events are events that do not influence each other. These are events that occur in a sequence where the outcome of one does not affect the outcome of the other. Some examples: tossing a coin while rolling a dice, picking an item and then putting it back before picking another. We have this special notation again. So the special notation, this first one means and. Again, I kind of choose to think about this as an N. The other one means or. So when looking at this formula, if A and B are independent events, the probability of A and B is equal to the probability of A times the probability of B. So here's kind of a clip art for you. If you notice these two events, the idea of and is that they're going to have something that overlaps. So if we want the probability of both, their probabilities will be multiplied. Dependent events are events that influence each other. Events that occur in a sequence where the outcome of one changes the outcome of another. For example, picking an item and not replacing it before picking another. Think about that. If you were to have a bag with names in it and you needed to draw two names, you would pick a name, you would hold on to it, and you'd pick the next name. The probability of the second is going to be altered because now there are one fewer names to choose from. If events A and B are dependent, the probability of A and B is still the probability of A, but now it's times the probability of B after A. So if you had a bag with 5 different names in it, and you drew one and took it out, thinking about your probability, now there are only 4 things to pick from, so this probability of the second has been affected. Reading through this scenario, classify it as independent or dependent, and then find the probability. It says you flip a coin and then roll a fair 6-sided die. These are independent events because the probability of one the probabilities are not connected. So finding the probability of getting a heads on a coin and rolling a 1. Well, the probability of a heads is 1 out of 2 possible combinations, and the probability of rolling a 1 on the number cube out of 6. So this is a probability of 1 out of 12. A bag contains 8 red marbles and 4 blue marbles. You randomly pick a marble and then pick a second without returning the 2. These events are going to be dependent because the probability of picking, well, how many are in the bag? We have 8 red and 4 blue, so there's a total of 12 marbles. So the probability of me picking a red marble is 8 out of 12. However, for the second draw, without returning means I'm going to hold on to that. And how many blues are there? Well, there's still 4 blues in the bag, but there are only 11 to pick from. So multiplying fractions, we multiply tops with tops. Tops and tops. Bottoms with bottoms. All right, letter C. It says a box of chocolates contains 5 milk chocolate, 5 dark chocolate, and 5 white chocolate. So there's a total of 15 chocolates. You randomly select one chocolate, eat it, and then select another. This again is an example of dependent events because you are not replacing the first item. There are 5 milk chocolate out of 15 out of 15 chocolate candies. And what's the probability of you then selecting a white chocolate? Let's see, well, there's still 5 white chocolates, seeing that you picked a milk chocolate, but now there are only 4 left in the box. Multiply tops with tops. Whoops, I can multiply tops with tops and bottoms with bottoms. A cooler contains 10 bottles of sports drinks, so I don't have to add anything up. There are 4 lemon lime, 3 orange, and 3 fruit punch. You randomly grab a bottle and return it to the cooler until you found your favorite one. Because you're returning that item, also known as replacement, these are going to be independent events. Because the probability of you picking an orange is 3 out of the original 10. And the probability of you picking a fruit punch, if you put that orange back until you found your favorite, there are now still 10 bottles in the cooler, and there are 3 fruit punch. Multiply tops with tops, bottoms with bottoms. If events are independent, then the probability of A and the probability of B is you multiplying the probability of event A times the probability of event B. So these are no longer story problems, but I'm giving you probability of A, B, and the probability of A times B. If the events are independent, then this is going to hold. So check that. If I were to take the probability of A, multiply it by the probability of B, it should equal the probability of A and B. Do these things equal what they're supposed to? So that's going to give me 27 tops and tops. Multiply the bottom. Oh, I should probably get a calculator for this. 12 times 15 is 180. So when I reduce, yeah, it ends up equaling. Let's try it over here. If I take the probability of A times the probability of B, it needs to equal the probability of A and B. Does it? So this is 20 over 90. Yep, these two things end up equaling. So I'm asking you to use the given probability to determine if events A and B are independent. Yes, these are independent events. Both that one and this one, because it upholds the formula. All right, last one. It says Jack rolls a 6-sided die and a 4-sided die. So here's a 6-sided die, it's a cube. A 4-sided die is a triangular prism. There's 1, 2, the third side is back here if you can kind of picture it. And then there's one more at the bottom. So there are 4 faces. Make a sample space of the possible outcomes. Well, I could roll a 1, a 2, a 3, a 4, a 5, or a 6 on the first die, and then I could roll ones on the triangular one. I could do 1, 2, 3, 4, 5, 6 on the dice, and I could roll 2s on the triangle. Again, 1, 2, 3, 4, 5, 6 would be an option on the dice, and I could roll 3s on the triangle. So what I'm doing is I'm trying to list all the possible combinations of these rolls. And you can do it in all sorts of different ways, but drawing out the sample space meaning all the types of events or the options that could occur, and they wouldn't occur in this linear type of a pattern, but just making sure you have all of the options. So I could get a 1 with any side of the dice, the 6-sided dice. I could get a 2 on the triangle and 1 through 6 on the cube. I could get 3s on the triangular and 1 through 6 on the cube, and 4s on the triangular and 1 through 6 on the cube. So what this helps with is to find the probability of A. It says let event A equal 6-sided die landing on 5. So what's the probability of the 6-sided die landing on a 5? Well, it could happen, let me change. It could happen here, it could happen here, here, or here. So there are 4 different times that it could land on a 5 out of how many options? Well, there's 1, 2, 3, 4, 5, 6. 6 times 4, so there are 24. So 4 out of 24 is the probability of you getting a 5 on the 6-sided dice. Event B, it says let event B equal the sum of the dice is 7. So the number of ways that the dice could sum to 7 are what are circled here in green: 6 and 1, 5 and 2, 4 and 3, and 3 and 4. These should be the only ways that you can make 7 by adding. There are 24 total options, as mentioned in finding the probability of event A. So we have 4 out of 24 again. So 1/6. Now the next one is asking for the probability of A and B. So there are still 24 total options, Well, what's the probability of A and B? Meaning, what's the probability of rolling a 5 and having the sum of 7? 5 with a sum of 7, your only option is this one. So it's asking, are events A and B independent? Well, mentioned on the previous slides, in order to determine if things are independent, we should be able to check that the probability of A times the probability of B is going to equal the probability of A times the probability of B. So it just so happens that you guys found all of these probabilities. So the probability of event A was 1 out of 6. The probability of event B was 1 out of 6. And the probability of event A and B, we ended up calculating as 1 over 24. But if you look at this, 1 times 1 is 1, 6 times 6 is 36. So these sides aren't equal. So because they're not equal, are the events independent? No. These are dependent events, and think about why. The idea of a sum, the sum is going to depend on the first roll and on the second roll. You need 2 of them. So when we found the probability of A and B, they are dependent events. Determining what you rolled on the first will be needed for that sum for the second. So these are dependent events. When we found the independent events, both sides equaled. Because they're dependent, it says if events A and B are independent, then this is going to be, this holds. Think about it the other way. Because this didn't hold, this right here wasn't true on the thing that we just looked at, then these events were not dependent. So I think that concludes this lesson. Please let me know if you have any questions. Thank you so much.